One rule you may notice in chemistry is that a lot of the so-called rules you learn actually have a ton of exceptions, and ionization energy is no different in that regard. So one might expect your ionization energy to increase throughout, but this is clearly wrong because nitrogen has a greater ionization energy than oxygen, so that bucks this trend. Now, as a quick refresher, right, the reason you'd expect ionization energy to increase left to right is because electronegativity increases left to right because there's a greater number of protons but the same number of core electrons. So that effective nuclear charge increases, therefore increasing Coulombic attraction and making it take more energy to ionize that electron. So clearly this doesn't paint the whole picture. And to understand it better, we need to look at electron configuration stability. So what we'll come to realize is that a full valence energy level is more stable than a full subshell. And a subshell, in case you're unfamiliar, is like a 2p or a 3s, stuff like that. And then that's more stable than a half full subshell. Now, the reason a half full subshell is more stable than a random configuration that isn't one of these three is because of quantum effects that are kind of outside the scope of general chemistry. But to summarize, it comes down to the fact that it's symmetric, and because it has a lot of exchange energy. And exchange energy is basically saying, okay, if I have these electrons in degenerate orbitals and they have the same spin, they're able to exchange with one another in more potential ways, therefore decreasing the energy compared to like if I add an extra electron right there. And all of this kind of comes into play when you look at ionization energy because it will convert the electron configuration and therefore change the stability. So if we look at nitrogen versus oxygen, we'll see that for nitrogen there's 3 2p electrons versus for oxygen there's 4 2p electrons. So what does this mean? This means that nitrogen, upon being ionized, is going to lose that electron. It's going to go from half full to not half full. Oxygen, upon being ionized, will lose this electron. So it will go from being not half full to being half full. So now what does this indicate further about stability? This means that nitrogen is going to become less stable versus oxygen is going to become more stable because it will change to a more stable electron configuration. So now, looking back at those numbers originally at the top, we can see that because oxygen is becoming more stable, it's going to take less energy to ionize that electron compared to nitrogen, which is actually becoming less stable. So kind of in summary for all this, when you're looking at ionization energy, it's super important that you look at these two factors. One being Coulombic attraction, in other words, kind of electronegativity, and the second one being electron configuration, and more specifically, the relative stabilities of those, which we can see right here. I'm highlighting. And yeah, so if you see full subshells or half full subshells, be on the lookout for potential exceptions in regards to ionization energy.